Welcome students to Lesson 4 in our unit on proportions and ratios. In Lesson 4 we will be talking about similar figures. Our essential questions for this unit, or for this lesson, is what are similar figures and how can I use similar figures to find missing measurements. First of all, let's look at two types of figures that we'll be talking about in this lesson. Congruent figures are figures that must be the same shape and the same size. And you can see that in the pictures of the stop signs here. They are both the same shape and the same size. The other figure that we'll be talking about are called similar figures, and they must be the same shape, but they can have a different size, which you can see here by the blue stop signs. They do have the same shape, but they have different sizes. One is definitely bigger than the other. Now, some characteristics about similar figures that are important to note are similar figures are always labeled with this symbol. Anytime you see this symbol, it means similar. Similar figures must also have equal corresponding angles, and similar figures must have proportional sides. Let's talk a little bit about proportional sides. As you look at these two figures, you can see that one is smaller and one is larger, and they each have individual measurements on the sides. They are, however, similar. That's what this symbol means, that they are similar. Now, our task is to write a ratio for each shape and then compare those ratios. So let's do that. If we were to write a ratio for this shape, let's start with the top measurement of 2. We'll use our colons to 3, to 1, to 3. And then let's write a ratio for this figure here. We'll start again with the top, and we'll move in the same order that we did with the smaller figure. So 4 to 6, to 2, to 6. Now when we look at these two ratios to compare them, we do notice that the smaller ratio is half of the larger ratio. They are similar even though they are different sizes. So now let's move on to two specific types of similar figures. One of the types of similar figures is called enlargements, which is what we saw on the previous slide. A smaller figure is similar to a larger figure. The example we have here is a photograph. When a photograph is enlarged, it's still a similar photograph. It's just bigger in size. The opposite is also true for reductions. When you start with an enlarged photograph, you can shrink that same photograph and they are still similar. Let's talk a little bit about enlargements and reductions. Take a look at these two figures. Which do you think is occurring here? Is this an enlargement or a reduction? And as you can see, we're starting out with a larger figure and going to a smaller one. So this is a reduction. Now let's talk about how we would solve for the missing side. So what we can do is begin by writing a ratio for each figure. And let's start with the height of this larger triangle. So 12 to 15 to 9 will be our ratio for the larger triangle. And then let's write a ratio for the smaller triangle following the same pattern. We'll start again with the height, which is 4. This is the unknown side, and 3 is the smaller figure. Now as we compare the two ratios, we can see that the larger triangle has been reduced by a factor of 3. 12 divided by 3 is 4. 9 divided by 3 is 3. 15 divided by 3 is 5. So our missing side is actually 5. Now that's one way to look at how we would solve for a missing side. Let's look again at two similar figures, and this time we're going to create a proportion to solve for an unknown side. So let's begin by setting up our ratio for the smaller figure. We will write 4 fraction bar 2 as our ratio, and we will set that equal to 24 fraction bar x. Now notice the order in which I wrote my ratio. I started with this side measurement and then went to the top measurement, and that's what I must do with the larger figure. Start with the side measure and solve for the top measure. So let's create an equation here by using cross products. So 4x equals 2 times 24, which is 48. We're going to isolate the variable with inverse operations. 4 divided by 4 is x, and 48 divided by 4 is 12. So our missing side here is 12. Now let's look at the next slide here, which talks about using proportions to solve similar figures in real life situations. So the question here is, how tall is the tree? Sam tried using a ladder, a tape measure, ropes, and various other things, but still couldn't work out how tall the tree was. But then Sam has a clever idea. Similar triangles. Sam measures a stick, which you can see right here, and its shadow, which you see here, and also the shadow of the tree. What the unknown is how tall the tree is. And this is a representation of what he's done. Now, Sam makes a sketch of the triangles, which is what you see here. The height is unknown. The base, which is the shadow of the tree, is 2.9. The height of the pole is 2.4. And the base of the shadow of the pole is 1.3. So Sam makes a sketch of the triangles and writes down the height to length ratio for both. And that's what we want to do also. We will start with the height to length ratio for both. So our ratio would look like height over 2.9, which equals 24 over 1.3. And again, we want to be consistent in our pieces and the things that we are listing. So let's use cross products. 1.3 times h equals 2.9 times 2.4. 9 times 4 is 36. 2 times 4 is 8, plus 3 is 11. 2 times 9 is 18, carry the 1. 2 times 2 is 4, plus 1 is 5. 6 plus 0 is 6. 1 plus 8 is 9. 1 plus 5 is 6. And we have 2 decimal places. 6.96 is the result. Now we need to isolate the variable by using inverse operations. 1.3 divided by 1.3 is 1, so we have h equals, and we'll have to do some calculating off to the side here, 6.96 divided by 1.3. We must move this decimal. That puts the decimal here. 13 times what is 69? So let's try 13 times 4, 52. 13 times 5, 65. That would be the closest we can get. So it goes in 5 times, and that gives us 13 times 5 is 65. So let me erase this to give us some more room to calculate. 13 times 5 is 65. 6 minus 6 is 0. 9 minus 5 is 4. Bring down our 6. 13 times 46. 52 is too much. 13 times 3 is 39. So we have 39 here. We have to borrow from the 3. 16 minus 9 is 7. And we'll go one more so that we can round to the tens place. 13 into 70 goes, should be 5. That's 65. And we'll stop there. Our answer then is going to be 5.4 because the 5 tells us to round here. So H equals 5.4. The height of the tree is 5.4. I'm going to erase some of this off of here just to keep it from looking so messy. Now let us check our answer, and that is correct. The tree is 5.4 meters tall, and Sam didn't even need a ladder. So let's summarize. We learned about 2 types of figures in this lesson: congruent and similar figures. Congruent figures must be the same shape and the same size. Similar figures, we learned several things about similar figures. They must be the same shape, but will have a different size. They must have equal corresponding angles. Similar figures must have proportional sides. They will always be labeled by the similar symbol. Enlargements and reductions are 2 types of similar figures. We've also learned how to create a proportion to solve for the missing side of a similar figure. There are 3 steps involved in that process. First, we create a proportion. Second, we use cross products. And third, we solve for the missing value. Now students, there are some practice problems for you to solve in your guided notes page. Please make sure that you do that.